Hi, my name is Jim Armbruster, a software engineer at Cyborg, where we're making AI infrastructure more secure. Now, what I'm about to show you is a real attack on a production-style AI pipeline. Here, I have a simple setup. We take sensitive text data, generate embeddings using a standard model, and store them in a vector database, in this case, Qdrant. This is exactly how most AI applications are built today. We'll start by inserting some realistic sensitive data. Things like social security numbers, passwords, medical records, and personal information. We generate embeddings using OpenAI's embedding model and store them in the database. At this point, everything looks normal. This is standard ingestion for a RAG pipeline. Now we simulate an attacker. Instead of going through the API, we access the underlying storage directly. In this case, memory mapped files. This is just one of many attack vectors. In most vector databases today, embeddings are not encrypted in use and often not protected beyond basic access controls. So if an attacker gains any level of privileged access, whether through a misconfiguration, vulnerability, or other side channel, they can extract the raw embeddings. Here we scan the memory and identify vectors by their structure, sequences of floating point values. Now we have the embeddings, not the original text, just the embeddings. The assumption many security experts make is that embeddings are abstract, that they just go one way, and that they're safe. But they're not. Now we take those embeddings and run them through an inversion model. This is an open source model called vector-text, which is trained to reconstruct original data from embeddings. And now we'll run the reconstruction. Here's the original text, and here's what we recovered from the embedding. Social security number, nearly exact match. Password, exact match. Medical diagnosis, exact match. Across multiple examples, we're reconstructing with extremely high accuracy. So what does this mean? It means vector embeddings are not anonymized and they're not one-way hashes. They're actually representations of the original data and under the right conditions can be fully inverted. Because most vector databases store and process their embeddings in plaintext, extracting them has become trivial. That's why the AI knowledge layer has become such a high-value target. If an attacker gets access, they don't just get your vectors. They get your underlying data and potentially your entire organization's knowledge. You can try this example yourself on Cyborg's GitHub repo.